Hi, my name is Robin and you're welcome back to my channel. In this video, I will be teaching you how to solve quadratic equation using the graphical method. Let's dive right into it. Hi, let us quickly go through the introduction to graphical method of solving quadratic equation. Now, let's take for an instance that we have a quadratic equation x squared minus x minus 6 is equal to 0. We know that we can solve this equation, okay, to get the value of x, okay? So x will be 3 or minus 2. This is called the roots of the equation, okay? Good. But when it comes to graphical method, you'll be given a quadratic function. Y is equal to x squared minus x minus 6. You can see that my x squared minus x minus 6 is the same thing as this left hand side here. Okay? Y the right hand side is equal to 0. So it simply means when you are given a function here, we already know that we can get the root of this equation when it's equal to 0. So for a graphical method, I'm going to write it here. For a graphical method, the roots of the function is when the function, let me write it in another way. The root of the function is the values of x when the function is equal to 0. You can see here that x squared minus x minus 6 is equal to 0. And I was able to get x equals to 3 or x is equal to minus 2, which is the root of the equation. So when the function is equal to 0, this is what I have, which is the same thing as this. So the function, when the function is equal to 0, when y is equal to 0, then you can get the root of the equation. So the root of the equation of the function is when the function is equal to 0 for a particular value of the given variable x. So let me go deeper here. Remember, y is equal to x squared plus x minus 6. And the quadratic equation, which is this, we can factorize, right? This is x, 3, 2, minus, plus. So here, x is equal to 3 or minus 2. Now, because x is equal to 3 or minus 2, let's decide to put the value of x as 3 and x as minus 2 to see what the function y will give us. So when x is equal to 3, y is equal to x squared, that is 3 squared, minus 3 minus 6. So this is 9 minus 3 minus 6, which is equal to 0. Then when x is equal to minus 2, this is minus 2 squared minus minus 2 minus 6. So this is 4 plus 2 minus 6. And this is equal to 0. You can see that the value of, you can see the root of the equation when substituted into the function, our function is equal to 0. That is why I said for you to get the root of the function, okay, if you want to get the root of a function, you have to make the function equals to 0. So that is the only case you can get the root of a function. So now, if I just decide to try to create a table, let's say x and y, okay? let's say x and y. Okay, x and y. So the lowest value of x is -2. Okay, so let's say -2, -1, 0, 1, 2, 3. So let's put -3. Let's just say I'm making that 3. The reason why I'm stopping at 3 is because the highest value of x is 3. Okay, I can still stop in 4, it doesn't matter, but the most important thing is that you cover the range of value of -2 and 3. Okay, so now when x is equals to 3, when x is 3, what was y? Y was 0. You can see when x is -2, y also 0. So the root of this equation or of this function is -2 and 3, because that is where the value of y is equal to 0, as we already know that for now. So let's try to fill up minus all these other values. So when x is equals to -3, okay, so that is -3 is equals to -3. So that means y is equal to -3 squared bracket -3 minus 6. Okay, so this is 9 plus 3 minus 6. So this is 12 minus 6, which is 6. So y is 6 when x is -3. So when x is -3, y is 6. Okay, then let's do for -1. When x is equals to -1, let's get y. -1 squared minus -1 minus 6. This is 1 plus 1 minus 6. This is 2 minus 6. So this will be -4. So when x is -1, y is -4. Okay, then the next one, when x is equals to 0, so y is equals to 0 squared minus 0 minus 6. So this will be -6. So -6 when x is 0. Then let's do for 1. When x is equals to 1, y is equals to 1 squared minus 1 minus 6. So 1 minus 1 minus 6, this is -6. So when x is 1, y is -6. Then when x is equals to 2, so this is 2 squared minus 2 minus 6. So this is 4 minus 2 minus 6. 4 minus 2, that is 2. 2 minus 6, that is -4. So this is -4. Okay, so but let's assume I'm just stopping on 3. Okay, I'm stopping on 3, so I'm not including 4 here. So you can see now that we can easily get values of y if we know the ranges of x value. In this case, x ranges from -3 to +3. See, -3 to +3. So for the value of -3 to +3, I know the value of y. You understand? So this is how you can generate values of y, given that you know the values of x. But remember that the root of the function is when the root of a function is gotten when the value of that function is equal to 0. You can see my function is y here. So the root of the function will be the point where the value of y is equal to 0. And the value of y is equal to 0 here. So this is the root of a function. And the value of y is equal to 0 here. So this is the root of the function. So it simply means the root of this equation, if I make it an equation as it is here, it will be -2 or 3, which is what you have seen here. So this is just the way the graphical method is made. Now, let's talk about the shape of quadratic graphs. Now, generally, the shape of quadratic graphs is a parabola. Okay, is a parabola, which simply means that it can be this way or it can be this way. Okay, but first thing you need to understand here is what I'm going to explain now. Let's assume I have this. Okay, graph. This is y-axis and this is my x. This is point 0. So let's say I have something like this. All right. So this point here, let's call that point A. This point here, let's call it point B, and let's call here C. So the first thing we need to understand here is gradient. Gradient simply means a change in vertical over a change in horizontal. That means a change in x, a y over a change in x. But we are still going to take gradient in another topic, but I just want to use a little bit of gradient to explain something here. So here, when you have positive, when positive y or change in y is positive and change in x is positive, here gradient is going to be positive. Okay, that is this. Okay, then when your change in y is equals to positive and your change in x is negative, gradient will be negative. Okay, when your change in y is negative and your change in x is positive, our gradient will be negative. Okay, then here, when your change in y is equals to negative and your change in x is equals to negative, our gradient will be positive. This is just saying plus divided by plus is plus, plus divided by minus is minus, minus divided by plus is minus, minus divided by minus is plus. So why do we need this? I will explain now. So the reason why we need this is that between point 0 to A, which is here, between this to A, you can see here that the value of y, y increases this way and x also increases this way. So as I'm going up from 0 to A, y is increasing. You can see y is increasing because this is increment. So you can see y is increasing here. Y is increasing. And as I'm going to 0 to A, x also is increasing because x is starting from here. But now at point A is here. So x is increasing. So if you look at between 0 and A, you will see x has increased, y also has increased. So you can see that the gradient in that place is equal to plus, because y is increasing and x also is increasing. So the gradient is positive. So now, if I check between A to B, let's see between A to B. This is between A to B. You can see here, I'm coming down from A to B. That means value of y is decreasing this way, okay? Value of y is decreasing, so that is minus change in y divided by. But as I'm coming from A to B, the value of x is still increasing. That is plus change in x. So gradient at that point is going to be negative, okay? Gradient is negative. So gradient here is positive, while gradient here is negative. So what do you think is going to be gradient between B to C? Pause the video and let me know what you think. Yes, correct. The gradient is going to be positive. So gradient will be positive. Why? Because if I move from B to C, it tells you that y is increasing as x also is increasing. So the gradient will be positive. Now, I would like to explain turning point, since you already know where the gradient increases or where the gradient is positive or negative. Now, at turning point, what do we really call turning point? Look at it here. Remember, between 0 and A, gradient is increasing. That is a positive gradient. Between A and B, gradient is negative, right? So, at point A, what is happening at point A? The gradient changes from positive to negative, because at point A simply means before point A, gradient is positive. After point A, gradient is negative. So at point A, that is where the gradient changes from positive to negative. So at that point, that is what we call the turning point. Why? Because it's turning from a positive gradient to a negative gradient. So at point A, where the gradient changes from positive to negative, it is called the turning point. So when someone asks you what is meant by turning point in quadratic graphs, turning point is the point where the gradient changes from positive to negative, or where the gradient changes from negative to positive. That is why we call it the turning point. So how many turning points do we have on this graph? A is a turning point. Why? Because that is the point where the positive gradient changes into negative gradient. Then B also is a turning point, because that is where the gradient that is negative changes into positive. So we have two turning points here. Now, at each of these turning points, it can be either maximum or minimum. Now, see, at point A is a turning point. That is the maximum of y. At point B is also a turning point. That is the minimum of y. So at point A, such point is where you have your maximum value. At point B, such point is where you have your minimum value for y. So now that we know what is meant by positive gradient, negative gradient, and a turning point, let's see how we can use this. Now, let's assume we have y is equal to x squared. Okay? So let's assume that x ranges from -1 to +1. So that simply means x, y. I can quickly put a kind of little thing here, -1, 0, and 1. Okay? So we can find the value of y when x is -1, 0, and 1. So when x is equal to -1, y is equals to minus 1 all squared, which is 1. So this is 1. So when x is equals to 0, y is equals to 0 squared. So this is 0. So when x is equals to 1, y is equals to 1 squared, and this is 1. So we can easily just put a small graph here. This is y, and this is x. Okay, this is 0, this is plus 1, and this is minus 1, because that is the negative of x, and this is the negative of y. Okay, so when x is minus 1, when x is minus 1, this is x. When x is minus 1, y is 1. Okay, so let's say this is 1, and this is 2. Okay, so when x is minus 1, y is 1. So that is, it is this point, because x is minus 1. Okay, x is minus 1 like this, x is minus 1 like this, and y is 1. 1 is 1 like this. So they meet here. So this is the point. Okay, so I just wanted to know how to get those points there. So let me remove this. Yes, so this is the point. Then when x is 0, when x is 0, which is here, y also is 0. So this is another point here. When x is 0, y is 0. This is another point here. Then when x is 1, y is 1. This is the point here. So we have 3 points, okay? So the point is this. You see that? Okay? Now, that is one part. Now let's say y is equal to 2x squared. Okay? When x equals to 2x squared. So let's also get x and y. Okay? So let's say we are still using x and y. And this is minus 1, 0, and 1. So let's get y value. So when x is equals to minus 1, so y will be 2 bracket minus 1 squared. So y is equals to 2. That is that. Okay? So when x is equal to 0, y is equals to 2 bracket 0 squared. So y is equals to 0. Okay? Then when x is equal to 1, that is 2 bracket 1 squared. That is 2. So you can see that the difference between this one and this one is just that the coefficient of x squared is having 2. So it's just that multiplying this by 2. 2 times 1, 2. You can see that. 2 times 0, 0. 2 times 1, 2. So in this case, if I plot the graph y-x, okay, and I have this is 1 and this is 2, this is 1 and this is 2, okay, this is minus 1 and this is minus 2, okay. So when x is minus 1, y is 2. So that would be a point here. Okay. When x is 0, y is 0. This is a point here. When x is 1, y is 2. This is a point here. So you can see I still have this. Okay. Now, conditions of quadratic graphs. I have 3 conditions that I'm going to share with you. So, condition 1. Condition 1 is when your function is ax squared. Okay? Condition 2 is when your function is ax squared plus c. Condition 3 is when your function is ax squared plus bx plus c. So now let's see what happens when we have these conditions. Now let's take condition 1. Condition 1 is when the function is equal to ax squared. Now, this condition can be in two ways. Okay, the first one and the second one here, I will explain. Okay, so let's put a kind of line. Okay, the first one is that y can be this, that means a here is greater than 0. Y can be minus ax squared. That means a here is less than 0. So y is equals to ax squared. There are 3 points you need to know here. Point one is that a is greater than 0 for this point, for this function. That means your curve is symmetrical. Your curve is symmetrical on y-axis. Okay, symmetrical simply means, you can see, it's cutting the curve into two, so it is symmetrical on y-axis. That is the first point. Okay, second point you need to know here is that when it's symmetrical on y-axis, you see here, you can see, what can you have there? That is the minimum point. The minimum point. So it simply means the magnitude of A determines the gradient. Okay, I will explain what this means. Let's do the same on this side. Point one for this. A is less than 0. So it simply means the curve also is symmetrical on y-axis. So it becomes this. You can see, it becomes this. So when it's greater than 0, it opens up. When it's less than 0, it closes. Okay? Then point 2 here is that the magnitude of A determines the gradient. Why? Because if you look at here, the gradient is negative here, right? Y gradient here is positive, right? So this is the turning point. Here, the gradient is positive here. Y for this one, the gradient is negative. So you can see A determines the gradient. Then point 3. Point 3 here is that here, when A is greater than 0, you only have the minimum value of the function. You can see, because the curve opens up, you can only have minimum value. But point 3 here, since the curve is closing, you can have maximum value. So you only have the maximum value of the function. So these are the 3 cases for condition 1. We are going to be applying this when we get to solving questions. So let's go to condition 2. So condition 2, y is equals to ax squared plus c. For this condition, we have 4 aspects of this condition. So the first one is, y is equal to ax squared plus c. So we want to consider when a is greater than 0 and c also is greater than 0. So when a is greater than 0 and c is greater than 0, you have questions like this. Y is equals to, let's say, 2x squared plus 3. You understand that? Or you have y is equal to x squared plus 3. Because you can see a here is 1 greater than 0 and c here is greater than 0. Okay? Then for the next one, you have y is equals to ax squared plus c. But in this case, that is when a is greater than 0 and c is less than 0. Okay? So in that condition, you can have an example of y is equal to x squared minus 3 or 2x squared minus 5. You can see a here is greater than 0, a here is greater than 0. Okay, let me put it well so that you don't get confused. Y is equal to 2x squared minus 5. So you can see a here is greater than 0, a here is greater than 0, and c here is less than 0, c here is less than 0. Then the third can be y is equal to ax squared plus c, but this is when a is less than 0 and c is greater than 0. So when a is less than 0, we can have something like this: minus x squared, okay, plus 3. You can see a here is minus 1, is less than 0, but c is greater than 0. You can still have something like this: minus 2x squared plus 5. You understand that? Then the last aspect of that is y is equals to ax squared plus c. That means when a is less than 0 and c is less than 0. So in that case, you can have something like this, minus x. You can have something like this, minus 5. So these are all the cases you can have on this condition. Okay, so I will take these cases. So we have 4 cases here on this condition too. So you see the changes, how it moves from one side to the other side. Let's dive right into it. So now for case 1, y is equals to x squared plus 3. That means a is greater than 0 and c also is greater than 0. And we want to try x ranges from minus 1 to plus 1. So x ranges from minus 1 to plus 1. So I can say x and y. So minus 1, 0, 1. We'll get y value. You already know how to use this. So let's say when x is minus 1. So when x is equal to minus 1, what do we get for y? So minus 1 squared plus 3. This is 1 plus 3, and that is 4. So when x is minus 1, y is 4. Okay? Then when x is equal to 0, let's see what we get for y. 0 squared plus 3. This is 0 plus 3, which is 3. So when x is 0, y is 3. So when x is equals to 1 now, so 1 squared plus 3, this is 1 plus 3, and that is 4. So this is 4. So in that case, I can easily put a graph. This is y and this is x. Okay? This is 0. This is 1 and this is minus 1 for y, let's make that one come up a little bit. Okay, let's make that come up a little bit. So let's make that come a little bit up. So I can, yes, so I can say y. So this is 1, 2, 3, and 4. Okay, so when x is minus 1, y is 4. So when x is minus 1, when x is minus 1, y is 4. So I have a point here. When x is 0, y is 3. So I have a point here. When x is 1, y is 4. When x is 1, y is 4. I have a point here. So according to the point that I have, this will be like this. The curve is going to be here. Okay? That means the curve is intersecting with y at 3. Okay? So the curve is intersecting with y at 3. So here I can tell you the conditions that we have here, or what can happen here. You can see you are going to have minimum value. Okay? You can only have minimum value of y because it opens upward. Then what again? The curve is symmetrical. Yes, symmetrical on y-axis because it's cut into 2 on y-axis. Then what again? The curve intersect at y-axis. That simply means that the intersection is at C. Remember that this is C. Our C here is +3. Okay? So you can see the curve is intersecting with y at 3. Do you get that now? So definitely, if I have another question which is like y is equal to maybe x squared plus 7, the curve we have to intersect at +7. Don't worry, we'll see this as we continue. Okay, so here now, for this case 1, this is what is going to happen. So I can easily tell you now, a is greater than 0 and c is greater than 0, then in that case a is greater than 0 means the curve will open upward, and c greater than 0 tells us that the curve intersects at that value of c, which is +3. So now case 2, y is equals to ax squared minus c. Here a is greater than 0 and c is less than 0. So let x ranges from -1 to +1. Okay, let's see what is going to happen to a question like this: x squared minus 3. Okay, so here I will quickly just put a table: x and y, -1, 0, 1. Let's see the value of y. So here y is equals to x squared minus 3. So when x is equals to -1, so y is -1 squared minus 3. This is 1 minus 3, that is -2. So this is -2. Then when x is equals to 0, this is 0 squared minus 3, and this is -3. Then when x is equals to 1, 1 squared minus 3. This is 1 minus 3. This is minus 2. This is minus 2. So here, let's put our graph. Okay? This is y and this is x. So I have 1 here, 0, and I have minus 1. I have minus 1, minus 2, minus 3, minus 4. And I have 1 and 2. So when x is minus 1, what is our y? Our y is 2. So when x is minus 1, our y is minus 2. When x is minus 1, our y is minus 2. So you have a dot here. When x is 0, our y is minus 3. So it's going to be here. When x is 1, our y. When x is 1, our y is minus 2, which is here. So our curve is going to be this. Okay? Our curve is going to be that. You can see our curve that here you can only have minimum value, right? Okay. And another thing is that the curve intersects the y-axis at C, because our C here, you can see, is minus 3. So the curve has to intersect at C, minus 3. And the last here is that the curve or the gradient changes based on value of A. So the gradient changes based on A value. Okay, so that is case 2. Now, case 3. Y is equals to minus x squared plus c. That means A is less than 0, as you can see. A is minus here, and C is greater than 0. C is plus here. So, for an example, we have a question like, let me say minus x squared plus 3. So let x value ranges from minus 1 to plus 1. So in that case, I have x and I have y. So I have minus 1, 0, 1. Let's get y value. So y is equals to minus x squared plus 3. So when x is equals to minus 1, that is minus, this is minus 1 squared plus 3. Sorry, let me write it properly so you can follow. So y is equals to minus 1 squared plus 3. So this is minus, this is 1 plus 3. So this is minus 1 plus 3, which is 2. So when x is minus 1, y is 2. So when x is equals to 0 now, y is equals to minus 0 squared plus 3. So y is equals to 3. This is 3. Then when x is equals to 1, y is equals to minus 1 squared plus 3. This is minus 1 plus 3. Then that is 2. So this is 2. So in that case, what we are going to have, y and x. So this is 1 and this is minus 1. This is 0. So this is 1, this is 2, and this is 3. Okay? So when x is minus 1, x is minus 1 here, y is 2. So you trace it, so there's a point here. Okay? Then when x is 0, y is 3. So there is a point here. Okay? Then when x is 1, y is 2 here. So there's a point here. So you can see our curve is going to be this. Closes downwards. So in that case here, our curve closes downwards. And you already know that if a is less than 0, curve always closes downwards. So here, what do you see here? You only have maximum value. Okay? Here, what do you see? You see that the curve intersects the y-axis at C value, or you can say the intercept of the curve is at C value, and our C value is +3, so the intercept is at +3. Then the last one is that the value of A determines the gradient. You can see here that the gradient here on this point is positive, while the gradient here is negative. So the turning point is at the intercept, which is C value. Now, case 4, y is equals to minus ax squared minus c. That is, a is less than 0. You can see because a is minus here, and c is less than 0 because c is minus. So that simply means if I look at something like this, minus ax squared minus 3, let x values ranges from -1 to +1. So in that case, I will have something like this: xy -1, 0, 1. So y is equals to minus x squared minus 3. So when x is -1, so that is x is -1 squared minus 3. So this is -1 minus 3, that is -4. So this is -4. When x is equals to 0, so this is 0 squared minus 3. So this is -3, this is -3. Then when x is equals to 1, 1 squared minus 3. -1 minus 3, and that is -4. So this is -4. So in that case, I have y and x. So 0, this is 1, and this is -1. This is -1, -2, -3, -4. 1 and 2. When x is -1, y is -4. So when x is -1, y is -4. So there's a dot here. When x is 0, y is -3. When x is 0, y is -3. There's a dot here. When x is 1, y is -4. When x is 1, y is -4. So there's a dot here. So you can see you are going to have your curve like this. Okay? So it simply means you only have maximum value. Okay? And 2 is that the intercept of the curve is at C value, because our C value is -3 and the intercept is -3, where the curve intersects the y-axis, and 3, the value of A determines the gradient. Good. That is all the 4 cases that we have on condition 2. Now let's take condition 3. For condition 3, y is equal to ax squared plus bx plus c. You can see here that the value of b is non-zero. Okay? The value of b is non-zero, because if the value of b is 0, for an example, if b value is 0, you can see you have y is equals to ax squared plus c, which is condition 2. Then you can go through all the cases. But in this case, the value of b is non-zero. So here, we need to see what happens when the value of b is either negative or positive. So I will make that a case. So that will be case 1. Okay? Case 1. When the value of b over a is positive. When the value of b over a is positive, the curve is displaced by minus b over 2a, and it is to the left of the y-axis. I'm going to explain this. So now I will show you by giving you an example. Let's say y is equal to x squared plus 6x plus 11, and x ranges from, let's say, +1 to -5. Okay, so here I can say x, y, this is -5, -4, -3, -2, -1, 0, and 1. So I will use my calculator and put x value as -5. So s value as -5. So -5 squared plus 6 bracket -5 plus 11. So in that case, I'm getting 6. Y will be 6. When x is -4, I'm getting 3. When x is -3, I'm getting 2. When x is -2, I'm getting 3. And when x is -1, I'm getting 6. When x is 0, okay, 0. When x is 0, definitely I will get 11. Then when x is 1, then I get 18. So here I know all my x values and my y values. So let's try to plot this, okay? Let's try to plot this. So here, this is my y and this is my x. So this is 0, this is 1, this is minus 1, minus 2, minus 3, minus 4, minus 5. And for y value, maybe we can use 2, 2 here. This is 2, this is 4, this is 6, 8, 10. Okay, 10. Yeah, that goes up to 12. Remember, we still have 18, but it doesn't matter. So let's plot this. When x is minus 5, y is 6. Okay, y is 6 when x is minus 5. So we have a dot here. Okay, when x is minus 4, y is 3. Okay, y is 3. Okay, so we have a dot here. When x is minus 3, y is 2. Okay, we have a dot here. When x is minus 2, y is 3. Okay, let's see, we have a dot here. When x is minus 1, y is 6. Okay, we have a dot here. When x is 0, y is 11. This simply means here. And when x is 1, y is 18, so it goes up. But the main point here is that if I connect all the dots together, which gives my curve, okay, not really connected well, but we can manage. Okay, yeah, so you will see that this curve is telling you that is on the left side of the y-axis. The reason is that if you look at b over a, what is b? Okay, in this equation, my b is plus 6, right? So b is plus 6 over, what is a? A is 1. So this is plus 6. So b over a is positive. And I said here, when the value of b over a is positive, the curve is displaced by minus b over 2a, and it is on the left of the y-axis. So you know why it is on the left of the y-axis, because b over a is positive. But now, let me tell you why it's displaced by minus b over 2a. If you look at minus b over 2a, so minus, what is b? B is 6, okay? Over 2 times, what is a? 1. So this is minus 3. So it simply means that the curve will be symmetrical on x is equals to minus 3. And that is here, you can see. So you can cut the curve into 2. It's symmetrical at that point. So that is why it is being displaced at that point. Easy. Don't worry. I'm going to take the next case, which is case 2. Now, I want to tell you, you can see from our curve that it's not cutting the x-axis. Now, what I'm trying to say is that if I have, for an example, something like this, you can see our curve is cutting the x-axis. And that point is what you call the root of the equation. So, what determines that nature is what we call discriminants. I have done this in my previous video. Discriminants. Discriminant D is given as b squared minus 4ac. Okay? When D is less than 0, it means the curve will not cut the x-axis. That is, the root of the equation. The root of the equation is complex. Complex meaning not a real root. So now let's see, based on our question here, if our d is less than 0, because I can see our curve is not cutting the x-axis. So here our a here is 1, our b is 6, and our c is 11. So let's get d. So b squared, that is c squared, minus 4ac. So this is 36 minus 44. So our d is minus 8. So you can see minus 8 is less than 0. So in this case, our curve is not going to cut the x-axis. Why? Because the root of this equation is a complex root. So that is why our x will not cut the x-axis. Okay? But in a case where you have d greater than 0, it means the curve will cut the x-axis, that is, the roots of the equation are real. They are real and different. They are real and different roots. So what real and different roots simply means is that your curve can cut like this. You can see this will be value of x, this value of x, root of the equation. This value of x here and this value of x here will be different, or your curve can be like this. The value of x here and the value of x here will be different. So they are real being that they cut the x-axis, and they are different because the x values are different. But in a case where your d is equal to 0, okay, then this means that the roots of the equation are equal and real. They are equal and real simply means you might have something like this. Your curve cutting x axis on just a value of x, or you can have something like that on just one value of x. That is why you can see some of the quadratic equation, you see x is equal to plus or minus 2. Do you understand that? So you will have just one value of x. Now this is case 1. Let's go to case 2. So case 1, like I said, when the value of b over a is positive, the curve is displaced by minus b over 2a, and it is to the left of y-axis. So let's go to case 2. Now case 2, when the value of b over a is negative, the curve is displaced by b over 2a, and it is to the right of y-axis. Let's see this by taking this example. Let's say y is equals to x squared minus 5x plus 4. Let's say x ranges from minus 1 to let's say plus 4. Okay, so we can put that here. So x, y, minus 1, 0, 1, 2, 3, 4. Okay, so when x is equals to minus 1, so minus 1 squared minus 5 minus 1 plus 4. So y is equals to This is 1 plus 5 plus 4. So y is 10. So when x is equals to 0, so this is 0 squared minus 5 bracket 0 plus 4. So y is equals to 4. Then when x is equal to 1, so this is 1 squared minus 5 bracket 1 plus 4. This is 1 minus 5 plus 4, which is 0. Okay? Then when x is equal to 2, so this is 2 squared minus 5 bracket 2 plus 4. And that will be 4 minus 10 plus 4. This is minus 2. That's minus 2. Then when x is equal to 3, so this is 3 squared minus 5 bracket 3 plus 4. This is 9 minus 15 plus 4. This is minus 2. Okay, then when x is equals to 4, so this is 4 squared 5 bracket 4 plus 4. This is 16 minus 20 plus 4. This is 0. So now let's plot the graph. Now plotting the graph, let's sketch it here. So this is y and this is x. So 0, this is minus 1, and this is 1, 2, 3, 4. And y value, let's use unit of 2. So this is minus 2, minus 4. So when x is minus 1, y is 10. So when x is minus 1, y is 10. So we'll put a dot there. When x is 0, y is 4. Put a dot there. When x is 1, y is 0. So we'll put a dot here. When x is 2, y is minus 2. So we'll put a dot here. When x is 3, y is minus 2. So we'll put a dot here. When x is 4, y is 0. So we'll put a dot here. So if we follow these dots, I'll try my best because it's freehand. Yes, we have this curve if you follow these dots. Here, you can see that my curve is on the right hand side. And the reason is because if I look for b over a, let's see, my b is minus 5 and my a is 1, that is minus 5. You can see that. So minus 5 is negative. So when the value of b over a is negative, the curve is displaced by b over 2a, and it is to the right of the y-axis. You can see the curve is to the right of the y-axis. Now, and it's displaced by b over 2a. Let's see, what is b minus 5? 2 times. So what is a? My a is 1. Yes, my a is 1. That will be minus. Oh, sorry. It is displaced by minus b over 2a, not plus here. So that is a mistake. That should be minus. Okay, minus b over 2a. So minus times minus will be plus. So that will be plus 5 over 2. So this will be 2.2. Okay, sorry, 2.5. This will be 2.5. 2.5 simply means here. So you can see that the curve can be symmetrical at x equals to 2.5. So that is the point there. Easy. Now let's continue. So now let's take a full example and put everything we've learned into use. The question says, plot the graph of y is equal to minus 2x squared plus 3x plus 6 for values of x from minus 2 to 4. So x values ranges from minus 2 to 4. So minus 2, minus 1, 0, 1, 2, 3, 4. Okay, so let's get y value. So we can say when x is equals to minus 2, let's see the value of y. So in this case, I'm going to be using calculator to make it very fast. So minus 2 bracket minus 2 squared plus 3 bracket minus 2 plus 6. So this will be minus 8. So this is minus 8. So minus 8. So when x is equals to minus 1, so I use minus 1 now. Minus 1. So that will be 1. Then I use 0. If I use 0, 0 here, that is 0. This is 0. So that will be 6. So when x equals to 0, so y is equals to y is equal to minus 2, 0 squared plus 3, 0 plus 6. So this will be 6. So when x is equals to 1, x equals to 1, minus 2, 1 squared plus 3, 1 plus 6. So let's put 1 here. So that will be 7. When x is equals to 2, so let's use 2 here. So y will be 4. When x is equal to 3, so we're using 3. So 3. Y will be minus 3. Then when x is equals to 4, okay, let's get y, 4. So that will be minus 14. So minus 14. Minus 14. So now we have our table. So now before plotting our graph, let's make analysis of the function. Okay? Analysis. Analysis simply means, okay, what is my a here? My a is minus 2. What is my b? My b is 3. And what is my c? My c is 6. Now, the analysis is that we know that when a is less than 0, okay, in this respect you can see our a is minus 2. When a is less than 0, the function is maximum. Okay, maximum in the sense of your curve is going to cover. Okay, it's going to cover. It's not going to be like this. It's going to be covering. You understand? It's not going to be open. So we already know that our curve is going to cover, right? Because it's going to have a maximum value. That is one of the analyses that we are able to know now. Okay. Then another thing here, that is that let's see on which side is going to be our graph, or let's find the discriminant. Okay, d is equals to b squared minus 4ac. Okay, what is my b? 3 squared minus 4 times, what is a? Minus 2. What is c? 6. So this is 9. Minus times minus is plus. So this is 8 times 6, that is 48. So this is 57. Okay, now you already know that if d, when d is greater than 0, in that case the root of the equation is real and different, right? So if it is real and different, it simply means it's going to cut the x-axis on two different values of x. So you can see it will cut here and it will cut here. Okay, now let's check our b over a. Our b is 3 and our a is minus 2. So this is minus 3 over 2. So this is negative. So since this is negative, we already know our curve is going to be on the right hand side, right? Good. So what that means is that most portion of our graph will be on the right, like this. You understand? You know, this one is showing almost equal, but most part of our graph is going to be on the right hand side, because our b over a is minus 3 over 2, which is negative. So you can see now that we're having something like this now, right? From here to here based on b over a. Now another analysis is that we can see what is our minus b over 2a. So minus, what is b? That is 3. 2 times, what is a? Minus 2. So this is 3 over 4. Okay? And 3 over 4 is same thing as 0.75. So 0.75 simply means the curve can be cut into equal half at x equal to 0.75. So that is another thing. So you can see, without even plotting the graph, I already know how my graph is going to look like, and where the value of the symmetry is going to be on that curve. Now let's plot our graph. Now we want to plot our graph, but I want to explain something here in terms of scales, because some of you might be taking an examination where you'll be asked to plot a graph and you'll be given a particular scale. So you need to understand how this scale works. Okay, so if you're talking about scale, okay, now they might tell you use 2 centimeter, or let me start with 1 centimeter first. Okay, they might say use 1 centimeter to represent 2 units on x-axis and 2 centimeter, or I said I want to start with 1 centimeter, sorry, and 1 centimeter to represent 1 unit on y-axis. Okay, I will explain centimeter and unit. You see that I have boxes here, okay, boxes, okay, I have boxes here, you can see, okay. Each of these boxes that you see from here to here is 1 centimeter. From here to here is another centimeter. So from here to here is 1 centimeter. From here to here is 1 centimeter. Okay, so this is 1 centimeter. From here to here is 1 centimeter. From here to here is another 1 centimeter. 1 centimeter. So it simply means from here to here is 2 centimeter. So you understand how that box works. But now in terms of unit, okay, in terms of unit, now 1 centimeter represents 2 units. When they say 2 units simply means you are counting in twos. 2, 4, 6, 8, 10, 12, like that. If they say 1 unit, it simply means you are counting in 1. 1, 2, 3, 4, 5, 6, 7. So here it's telling us that on our x-axis, let's assume I'm putting a line like this now. It's just an assumption, okay? So this is y and this is x. So it's saying on our x-axis, 1 centimeter represents 1 unit. Remember, from here to here is 1 centimeter. From here to here is another centimeter, another centimeter, another centimeter, another centimeter. So each of these centimeter, it says it represents 2 units on x-axis. 2 units, you already know you're counting in twos. So 1 centimeter is 2 units. Another 1 centimeter is another 2 units. This is 4. This is 6. This is 8. This is 10. That is how it works. But if the question says 2 centimeter represent 2 units, for an example, 2 centimeter represent 2 units. So for 2 centimeter representing 2 units, it will be, that means, remember, from here to here, this is 2 centimeter. From here to here is another 2 centimeter. From here to here is another 2 centimeter. From here to here is another 2 centimeter. So 2 centimeter represent 2 units. So to every 2 centimeter, we are putting 2 units. So that is 2, 4, 6, 8. Easy. If they say 2 centimeter represent 5 units, you already know you count in 5, 5, 10, 15, like that. So you already know how it works now. Now, let's use an appropriate scale for our graph, because at times you might not be given scale. You need to pick your own scale. So here, I'm picking an appropriate scale. I'm saying 2 centimeter to represent 1 unit on x-axis. On x-axis, you can see 2 centimeter represents 1 unit. While on y-axis, 1 centimeter to represent 2 units. 1 centimeter representing 2 units. You can see that. So let's plot our graph. When x is minus 2, that is here, y is minus 8. So we just trace our minus 2 to y minus 8. Okay, these are minus 2. Okay, we trace it to y minus 8. Y minus 8. Trace it to y minus 8. So if you look at that, this is a dot. Yes? When x is minus 1, y is 1. When x is minus 1, this is minus 1 here. And y being 1, that is half here. Okay? So there's a dot here. Then, when x is 0, which is here, 0, y is 6. So you just go straight from 0 to y 6. So there's a dot here. Okay? Then when x is 1, y is 7. When x is 1, y is 7. So 7 should be between 8 and 6. Okay? So here, there's a dot here. Then when x is 2, y is 4. So x is 2, y is 4. Okay? X is 2, y is 4. So here, there's a dot here. Now, when x is 3, y is minus 3. Minus 3 is between minus 2 and minus 4. Okay? So minus 3 should be here. Okay, so there's a dot here. Then when x is 4, y is minus 14. So minus 14 Okay, so there's a dot here. So you can see I have gotten my curve. So it is appropriate that you use a good instrument to shape your curve. But here I'm just going to use a free hand. Okay, I'm going to use a free hand. To use a free hand, okay. I will just see. Using a free hand, like I said, because I don't have any instrument to use, so I will just, yeah, yes, yes, yes. Yeah, I think this is okay. So this is my curve that I've plotted. You can see that it is almost the same with when we did the analysis without even plotting the graph. We saw how it's going to look like. So now in this case, let's take questions that we have for this particular graph. So now we see that we have to plot, which we have done. Use the graph to find the root of the following equation. Okay, A says we should find the root of 2 minus 2x squared plus 3x plus 6 is equal to 0. Remember that this is the exact equation here, which is a function here. Okay? So if I compare this with this, comparing it will be 2x plus 3x plus 6 is equals to y, right? Because this is y is equals to that. So it simply means you can see this one here is equal to this side here, right? That means y must be equal to 0. So it's telling us at y is equals to 0, what is the value of x? So this is y equal to 0. What is the value of x? Just go left or right. So if I go to the left, this is a point. If I go to the right, this is a point. So what it's telling us is that at y is equals to 0, where is the curve cutting the x-axis? And the curve is cutting the x-axis here and here. Okay? But remember, I just used a freehand sketch to join the curve, to join the points. You understand? So we might not have the exact point on this, but you might have a different kind of little bit value above mine or below mine. No problem. The most important thing is that you understand that y is equals to 0 is the point where the curve cuts the x-axis based on we have both sides to be equal. So here it simply means the root of the equation minus 2x squared plus 3x is equals to 0 are what is the value here? Because that is where the curve cuts the x-axis. That should be x is equals to 2.5, middle of 2 and 3, and that's it. This is close to 1 or little bit more than 1. So I would say or maybe minus 1.2. It doesn't matter. Like I said, the most important thing is that you understand what I'm saying. But you should get an accurate value if you use your instrument to join the points together. So in this case, the root of our equation is this. Now, if you solve this equation using quadratic formula, you should have the same answer. So the next question says, find the root of the equation for b when the equation is minus 2x squared plus 3x plus 2 is equals to 0. So we are looking for the root of the equation for this equation here. Let's compare it with what we have with our curve. Our curve is this, minus 2x squared plus 3x plus 6 is equals to y. Okay, that is our curve. But the difference between what we are looking for and our curve is that you can see on our curve is plus 6, but on what we are looking for is plus 2. So if I decide to add plus 4 here on both sides, this will be plus 2 plus 4. It will be the same left hand side here and the same left hand side here. While on the right, y will now be equal to 0 plus 4, which is 4. So at y is equal to 4, what will be the root of the equation? That is what the question is saying. So let's find y is equal to 4. This is y is equals to 4. So y is equals to 4, we just draw a line to the curve. Okay? You can see, drawing a line to the curve, we have done that. Where is cutting the curve is here. I will just trace it to x. Okay? And I'll trace this one to x. So that simply means x, which is the root of the equation with x is equals to 2 or minus 1.5. Easy, right? Good. Now, let's take c. Now, taking c, we are looking for the root of the equation when we have minus 2x squared plus 3x plus 9 is equals to 0. Now, let's compare with our curve. Our curve is minus 2x squared plus 3x plus 6 is equals to y. That is our curve. But remember, the only difference between our curve and what we have here, our curve is plus 6, but what we are looking for is plus 9. So how can I take plus 9 to plus 6? I will subtract 3 on both sides. So if I subtract 3 here, so plus 9 minus 3 will give us 6. So that means left hand side here is the same left hand side here. Y on the right hand side, y is equals to 0 minus 3, that is minus 3. So at y is equals to minus 3, what will be the value of our x? That becomes the root. So let's look for y is equal to minus 3. Y is equals to minus 3 is here, right? So let's draw a line through that to cut the curve. So drawing a line through that to cut the curve, so we trace that line up. You can see here is already x is equal to 3 here, as we know, x equals to 3 there. Or here, let's take it up. X is equal to, we can say, because this is 1.5 here, okay, this is 1.5. So we can say minus 1.4. Okay, it doesn't matter because I use the freehand sketch. But for you that you have the instrument to join your curve, you should have the exact answer. So my x is 3 or minus 1.4, which is the root of the equation. Now, question D. It says we find the root of the equation when we have minus 2x squared plus x plus 5 is equals to 0. Let's compare with our curve. This is our curve, minus 2x squared plus 3x plus 6 is equals to y. Now you can see this is very tricky because this is plus x and this is plus 2x. So what can we add to this that will give us our curve? Okay, so that is the tricky part. So let's take, let me bring this one down. Okay, let me bring this one down so you can see what I'm about to do. Okay, so here, you can see this is plus x, why this is plus 3x. So the difference between this one is 2x. Okay, so if I say plus x plus 2x, I will get plus 3x. Okay, then another thing here is that this is plus 5 and this is plus 6. So if I say this is plus 1, I will get plus 5 plus 1, that is plus 6. So if I had 2x plus 1 to both sides, okay, to this side, and to this side, I will get the same thing. So here, let me quickly write it properly so we can have an understanding. So I'm looking for minus 2x squared plus x plus 5. This is equal to 0, and this is our curve, 2x squared plus 3x plus 6, and this is equals to y. And if I had 2x plus 1 on this side, and I had it to this side, okay? So because my left-hand side now is equal to my left-hand side, so simply means right-hand side should be equal. So y is equal to, so at y is equal to 2x plus 1. I'm looking for x value. But this is tricky because y is now a linear equation. So in this case, you have to find the values to plot before you can find your root. So what I'm trying to say, so what it means is that, remember, our y here is for our quadratic. We put values of x in this to get all these values of y. In this case now, I want to find the value of y. So I'm putting L here to show its linear equation for this respective value of x. So when x is minus 2, that is 2 bracket minus 2 plus 1. So 2 times minus 2, that is minus 4. Minus 4 plus 1, that is minus 3. You can see that? So when x is 1, so I will do that now. When x is minus 1, 2 times minus 1, that is minus 2. Minus 2 plus 1, that is minus 1. When x is 0, 2 times 0, 0 plus 1, 1. When x is 1, 2 times 1, 2 plus 1, that is 3. When x is 2, 2 times 2, 4 plus 1, 5. You can see the difference between this one is, difference between 1 and 3 is 2. 3 and 5 is 2. So this will be 7 and this will be 9 because it is linear. Now let's plot. When x is minus 2, which is here, okay, y is minus 3. So when x is minus 2, which is here, y is minus 3. So that is a dot here. Okay. When x is minus 1, which is here, y is minus 1, which is here also, a dot here. When x is 0, y is 1. When x is 0, y is 1, which is here. Okay? When x is 1, y is 1. When x is 1, when x is 1, y is 3. When x is 1, y is 3, which is here. When x is 2, y is 5, which is here. Okay? When x is 3, y is 7, which is here. When x is 4, y is 9, which is here. Okay? So, let's join that. You will see is a linear, is a straight line. You can see that is a straight line. Is a straight line. Okay, now we have drawn our straight line, but where is that straight line meeting the curve? That is the value of x. So the straight line is meeting the curve here and here. Okay, here and here. Okay, so our value of x will be, what is value of x here? Value of x here is minus 1. Or what is the value of x here? Trace it down. Value of x here. That is like 1.75. 1.75. Okay? Easy. Now, in this question also, they can tell you what is the maximum value of y, or maximum value of the function. You already know the maximum value is the highest value of y here. Okay? So which is what here? At x is equals to 1. At x is equals to 1. Y is 7. So maximum value is y. So y max is 7 at x is equal to 1. Remember, it's easy. You just need to look at what you have on your graph. Now, I just need to let you understand that the values that I've gotten from my graphs might not be the same that you are going to get if you use the right instrument to join the points to make a curve, a very good curve. You understand? But the process is the same. So do not be bothered about the values I'm getting, because I used a freehand sketch to join my points together. Okay? So now in this case, I would like to introduce you to maximum and minimum points of a quadratic function. Okay, so the maximum and minimum point of a quadratic function. Given y is equal to ax squared plus bx plus c. I've explained this in one of my previous videos, but I need to actually tell you here. When a is greater than 0, you only have the minimum point. When a is less than 0, you only have the maximum point. So in a case where you have this equation, y, or this function, y is equals to x squared minus 5x plus 4. What is our a here? Our a here is 1, and 1 is greater than 0. It simply means in this case, this function can only give us minimum value. When you have something like this, minus 2x squared plus 5x plus 6, okay? Our a here is equal to minus 2. So we simply, and minus 2 is less than 0. So it simply means this function here can only give us maximum value of the function. But let's see how we can get our minimum point and maximum point with respect to the x values without even plotting the graph. Now, look at this question. We have to find the minimum and the maximum value of the following functions and the values of x at which they occur. So the first thing is you need to decide if it is the minimum value you can get or maximum value. Now, let's talk about a. Y is equal to x squared plus 5x plus 6. What is our a? 1. What is our b? 5. And what is our c? 6. Here we can see that a is greater than 0 because a is 1 and is greater than 0. And when a is greater than 0, what can you have? You can have the minimum value of the function. Okay? So in this case, we cannot have maximum value. We can only have minimum value. So we already know that we are looking for minimum value. Now, be it minimum value or maximum value, you need to take your function to be in a particular format. And that is the format of completing the square method. I'm going to show you how this is done. Just follow me. So now, you have y is equal to x squared plus 5x plus 6. Now, the coefficient of our x squared is 1. So, no problem. When the coefficient is more than 1 or less than 1, I will tell you what to do. That is why we have other examples. But for in this case, the coefficient of x is plus 1. So we are good. So what we need to do here is that I'm going to look for the coefficient of x having a power of 1. X having a power of 1 is this, right? I have done completing the square method before. For those of you that have not seen my video on completing the square method, click on the top right hand corner of this video. It is very, very compulsory so that you can fully understand this format. So here, the coefficient of x having power of 1 is 5, right? So what we need to do, you want to half it. You want to multiply by half. And that is 5 over 2. Then you want to square it. Okay? Now, we have that. So what I will do here, I will write x squared plus 5x. Okay? I'm leaving a space and I'll put plus 6 here. Let me do it close by. Okay? I will put plus 6 here. The reason why I'm putting a space is this. This 5 over 2 squared, I will add it here. 5 over 2 all squared, I have it there. Okay? Now, besides 6, I will put the opposite. That means subtraction. 5 over 2 all squared. Put subtraction on the opposite. So this is y is equals to x squared plus 5x plus 5 over 2 all squared plus 6 minus 25 over 4. Okay? So y is equal to, remember, this one here, I can write, like I said, I've done this in my completing the square method. This is x squared. I write x. I put this 2 outside. This is 5 over 2 squared. This is 5 over 2. Okay? The sign you put here is the sign of the coefficient of the variable of x having power of 1. So which is plus. Or if you don't want to go through that way, just say the sign here times the sign here. Plus times plus is plus. Okay? Then I have plus 6. What is the LCM here? This is 4. That is 24 minus 25. Okay? So this is y is equal to x plus 5 over 2 squared. So this is minus 1 over 4. Now, this is the format we are looking for. Now, what this means is that my y minimum will occur at a particular value of x, okay? Your y minimum is here, what you have here. That is minus 1 over 4. At what value of x? You know, x here is plus, this is plus 5 over 2. The opposite of plus 5 over 2 is minus 5 over 2. So it simply means for you to always get your y and your y minimum or y maximum at a particular value of x, we can write a given formula. We can write a formula to be ax minus h squared plus k. Okay, this formula here I will explain. Okay, h is the value of x where y is either minimum or maximum. Yk is my value of y if it is maximum or minimum. So let me explain this so you can understand properly. Okay, so if you compare this one with what we have, okay, plus k is equal to minus 1 over 4. Minus 1 over 4. So that means k is equals to minus 1 over 4. Okay, that is why y minimum is 1 over 4. So your y value minimum or maximum is always here. Then minus h, okay, minus h is equal to what here? Plus 5 over 2. So 5 over 2. That means h is equals to minus 5 over 2 or minus 2.5. Okay, minus 2.5. Okay, so that is why x is minus 5 over 2. So you see, it tells you that at x is equal to minus 5 over 2, y minimum is at minus 1 over 4. If you plot this graph, you will see that the minimum value of y, which is at minus 1 over 4, is having a x value, a corresponding x value of minus 5 over 2. Now, look at this for an example. We have this graph now. Y is equal to x squared minus 6x plus 3. Okay? We want to get the minimum point of this function and at what corresponding value of x. We can easily see from this graph when plotted that minimum value of y is minus 6. You can see that it's minus 6 at a particular value of x, which is at 3. Okay, that is plotting it, you can easily see it. But in a case where you are not plotting the graph and you still want to find your minimum point and the maximum point, which is the question that I solved previously. But I'm just going to show you using showing you why you have the graph here. So remember that the coefficient of x squared here is 1, right? Okay, is 1. So we can easily just have the coefficient of the variable x that is having 1. What is the coefficient? Minus 6. So minus 6 times half, that will be minus 3, and square, that is what we are going to use. So this is x squared minus 6x, okay? You leave space, then plus 3, okay? So what are you adding? Minus 3 squared. So minus 3 squared. Then here, 1 minute. Let me make it easy for you. So remember, this will be minus 3 squared is still 3 squared because minus times minus is plus. So I'm adding 3 squared. But remember here, you will add opposite minus, as we said. So y is equals to this one here. I can rewrite this one as this is x squared. This is x squared. And this is 3 squared. This is 3 squared. So minus times plus is minus. Okay? So everything here is same thing as x minus 3 all squared. So this is plus 3 and this is minus 9, right? So this is y is equal to x minus 3 all squared minus 6. Remember, this is the same compared to our general equation, which is this plus k. These are general equation. Okay? Our a here is 1. A is 1. Okay? X is x. Minus is minus. That means h is 3. And our k is minus 6. But remember, what is k? K is y value. That is the minimum because a is greater than 0 here. So it's y minimum we can get. So y minimum is minus 6. At what value of x? H is for x, which is 3. So you can see here, we have gotten x is equals to 3. That is where you have the minimum value of y. And you can actually see it from this graph. Y minimum is minus 6 at x is equals to 3. So you can see we have our minimum point. But remember that you can be asked to find the turning point. Turning point is the point where the gradient of the curve changes from either. So for example, look at this graph that we have here now. The graph that we have is like this. Okay? It's like this. Now, this is the curve. Okay? So on this curve, let's say this is point A, and this is point B, and this is point C. Okay. If you look at A to B is reducing, right? So the gradient of AB is negative. While the gradient of B to C is increasing, the gradient of B to C is positive. So point B is the point where negative gradient is turning into positive gradient. So at point B, that is the turning point. The turning point is the point where gradient changes signs from negative to positive or from positive to negative. And at that particular point, B, is where you have your minimum value of the function with the corresponding value of x. But do you know that there is a shorter way to get your minimum value without even going through the completing the square? You can get your minimum point or maximum point using this formula. Y minimum or maximum can be gotten using C bracket minus B squared over 4a. Write this formula somewhere so you don't forget. Okay, let's quickly analyze what we have. Our function here, a is 1, b is minus 6, and c is minus 3. So let's use this formula. We already know its minimum value because a is greater than 0. So what is our c? Our c is 3 minus. What is our b? Our b is minus 6. That is squared over 4 times 1. Right? So this is 3 minus. This is 36 over 4. Okay? And I can just quickly put it here. So y minimum is equal to 3 minus 36 over 4. That is 9. 3 minus 9. That is minus 6. You can see we got the same answer. So that is the shortest way to get your minimum value of the function or maximum value of the function. Now, back to our question. Let's use that formula now. Y minimum is equals to C bracket minus B squared over 4A. Okay? Here, what is our A? A is 1, B is 5, and C is 6. So C is 6 minus B is 5 squared. That is 25. 4 times 1. So C minus 6 minus 25 over 4. So here, this is 4. That is 24 minus 25. So y minimum is equal to 24 minus 25. That is minus 1 over 4. You can see we got the same answer here. Okay, now let's go to question B. Remember, question A, the coefficient of x squared is plus 1. That is why this is kind of easy. Now, when the coefficient is not plus 1, that is why we have question B and C. So let's see how to solve that. Now, let's take B. Y is equal to 2 minus 4x minus x squared. Let's rearrange this. So we have minus x squared minus 4x plus 2. Okay? You already know how to get minimum value very fast, right? So we can easily do that one. A is minus 1, B is equals to minus 4, and C is equals to 2. So here, is it maximum value or minimum value I'm looking for? A is less than, A is minus 1. That means A is less than 0. So in this case, it's maximum value. So y maximum is equal to using C minus B squared over 4A. What is my C? 2 minus, what is my B? Minus 4 squared over 4 times minus 1. So y max is equal to 2. This is minus 16 over minus 4. That is 2 plus 4, which is 6. So we already know that my maximum value of the function is at 6. But let's do it normally, okay? So you can see here now, the coefficient of x, x squared, is minus 1. So in that case, if it is plus 1, no problem. But if it is minus 1, you have to multiply through by minus. If I multiply through by minus, this is minus y is equal to x squared minus times minus plus 4x minus times, that is minus 2. You can see now the coefficient is now plus 1. So we now apply our normal rule that says the coefficient of the variable of x having power of 1 is plus 4. So you half that one, right? 4 times half, that is 2. Then you square it. So this is what I'm going to have. X squared plus 4x plus 2 squared, right? Then minus 2. But remember, you always put the negative minus 2 squared to that. So this is x squared plus. So here we have 4x plus 2 squared minus 2 minus 4. So minus y is equals to, remember this one here can still be this, x plus 2 squared, right? So this is minus 2 minus 4, that is minus 6. So because minus is still here, so multiply through by minus. So you have y is equal to minus bracket x plus 2 and plus 6, because minus is here and minus times minus is plus. So we have this now. And if you compare this to y is equal to ax minus h squared plus k, you can see our k is plus 6. Our k is plus 6, and that is our maximum or minimum value of the function, and that is y max is 6. Then our h, this is minus h plus 2, that is minus h plus 2, that is h is minus 2, right? Good. So, and that is the same value as our x. So you can see here that my y max is already 6. You can see we use that formula directly, we got 6 at x value of minus 2. So this is how to do that when your coefficient of x is minus 1. Okay, good. Now let's take question C. For C is equal to y is equals to 2x squared minus x minus 1. Okay, you can see here that the coefficient of x squared is 2. So in this case is greater than 1. Okay, so that is why I'm giving this example, so that, okay, so here all you need to do here is that you write something here, 2x squared minus x minus 1. Write this one here. Okay, it's equal to 0. So we want to make the coefficient of variable of x squared to be 1. So divide through by 2. Okay, divide through by 2. So this will be x squared minus 1 over 2x minus 1 over 2 is equal to 0. So once you have this, that the coefficient of x is now 1, come back here, right, this is 2, right? Write that 2, bracket, then write everything here. X squared minus 1 over 2x minus 1 over 2. You see that? Then the coefficient of variable x having power of 1 is minus half. So that is what I want to half. So I will half that like the way we normally do. We have, that is minus 1 over 4, and we square it, and that is 1 over 4. So this will be 2 bracket x squared minus 1 over 2x plus, this is 1 over 4 squared, so plus 1 over 4 all squared minus 1 over 2. Remember, you always put the negative of that, that is minus 1 over 4 squared. Okay, so this is y, 2 bracket. Remember, this one itself is x minus 1 over 4 squared. Okay, so you have minus 1 over 2 minus 1 over 16. Okay, so in that case I have x minus 1 over 4 squared. LCM is 16, so this is 8. Here 1, that is 8, this is 1. Okay, so this y is equal to 2. This is x minus 1 over 4 squared. This is minus 9 over 16. Okay, now we can use these two to open through the bracket. So y is equal to 2 bracket x minus 1 over 4 squared, right? Minus 2 times 9 over 16, that is 9 over 8. So this is now in the form of y is equal to this. So here, our a is greater than 2. Our a is greater than 1, so which simply means minimum value we can get. So y minimum is the value of k, right? And what is value of k here? Value of k here is minus 9 over 8. At what value of x? That is 1 over 4. Easy. Nice. Remember, you can still use your fast method. Y minimum is equals to c minus b squared over 4a. Our c is minus 1 minus our b is minus 1. Minus 1 squared is 1 over 4a. That is 2. So this is minus 1 over 8. And minus 1 over 8, that is minus 9 over 8. So you can see we have the same answer. Now, let's look at this question. It says, draw the graph of y is equal to 5 minus 2x squared. Let us rearrange this. This will be minus 2x squared plus 5. Okay? Now, if you recall, I've given you a case, a condition for this before. The condition that I gave you is this here, which is the same thing as here. Our a is 2. That means our minus a is minus 2. Our c is 5. So when you have this condition, you can see our a is less than 0. Why? Because it's negative. Our a is less than 0 because it's minus 2. And when a is less than 0, it simply means your graph, your curve is going to cover up. Okay? It's going to cover up. Cover up like this. Okay? It's not going to open. Okay? It's going to cover up. That is one thing that you need to know there. And the other thing here is that your curve will cut the y-axis at C. Okay? So if this is our axis, y and x, okay, your curve is going to cut the y-axis at C. Okay? At C. So here, our curve is going to cut the y-axis at plus 5. Okay? So let's look at the option that is closing up and cutting the y-axis at plus 5. So the first option here is closing up, good, and is cutting the y-axis at 5. So this is the answer, but let's check the rest. This one is closing up, good, but it is cutting the y-axis at minus 5. So that is wrong. The next one, this is closing up, good, but is not cutting the y-axis at any value. So that is wrong. The last one here, this opens up. Our curve should be closing up. So this is wrong. So our answer is first option, which is option 1. Now, next question. Draw the graph of y is equal to x squared minus 3x. Okay, here. What is a? A is 1. So that means a is greater than 0. If your a is greater than 0, you already know your curve is going to open up. Okay? Our curve will open up. That is the first thing. And the next thing is that, because this is, we can say b is minus 3, right? Another thing is we can decide to know where our curve will be, maybe on the left or on the right, by using b over a. What is my b? Minus 3. And what is a? 1. So this is minus 3. Now, if your b over a, you recall, when your b over a is negative, it simply means your curve is going to be on the right of y-axis. If your b over a is negative, it simply means your curve is going to be on the right of y-axis. It simply means you are going to have, if this is your axis, y and x, so your curve is going to be on the right of y-axis. That is right. Okay? Remember, this one can also be the right of y-axis. This can still be the right of y-axis. Okay? So you can have this condition or you have this. Okay? but it depends. Now, let's see what we have. Now, first option here, our curve is on the left. You can see this is fully on the, you can see from these dots like this, that is almost everything about the curve, though you still have the small part here, but our curve is solely on the left, so that is not correct. Though it opens up, but it's on the left, that is not correct. We need a curve that is on the right. You can see this opens up, good, and it's on the right, it's solely on the right. Okay, so let's keep that as an option for us. This one is closing up, so it is wrong. We need something that opens up. This one opens up, but it is not cutting x at any axis. Okay, it is not cutting x at any axis. So in this point, and it's not cutting x at any axis, and it is symmetrical. You can see it's both left and right. They are equally displaced on both left and right. So this is wrong. This is wrong. This is on the right, good, and it opens up, good. This is on the left and it opens up. So our option is second option, which is our answer. This option, this question, sketch the graph of y is equal to x squared minus 6x. Okay, our a is 1, so a is greater than 0. When a is greater than 0, your curve opens up. Then let's see where our curve is going to be, left or right. That means b over a is what we are going to check, and our b is minus 6, so minus 6 over 1, so we have minus 6. When your b over a is negative, that means your curve is going to be on the right. So that means our curve is going to be on the right. So it can be like this, okay, or it can be like this. Okay, it depends. So let's see. So let's eliminate those ones that cannot be. So if you look at this option here, option 2 here, our curve is closing, and we said our curve needs to open. So option 2 is wrong. Option 2 is wrong. Then if you look at option 4, it is symmetrical. It is both left and right. Our curve should be on the right. So option 4 is wrong. So we have option 1 and 3 to work with. Now, if you look at option 1, it opens up, which is good, but our curve is on the left, which is wrong because our curve should be on the right. So option 3, this opens up, good, and our curve is on the right. So option 3 is our answer. You can see, I'm just analyzing. I'm not calculating anything here. I'm not sketching, looking for x value, y value before we can draw and get our option. We're just analyzing to get our option based on what I've taught you. This question, sketch the graph of y is equal to x squared plus 4x plus 6. Okay, this is a full quadratic function. Our a is 1. That means a is greater than 0. When a is greater than 0, your graph should open up. That is 1. Our b is 4, and our c is 6. Now, because it's a full quadratic function, we can decide to say b over a, where our curve is going to be left or right. This is 4 over 1, which is 4. That means this b over a is positive, so our curve is going to be on the left, and it's going to be displaced, because it's on the left, it's going to be displaced by minus b over 2a. So that means minus, what is b? 4, 2 times a, 1, that is minus 2. So it's going to be displaced by minus 2. What displaced simply means is that it will cut. We already said it's going to be on the left. Okay, it's going to be on the left. And another thing before we draw, remember we can get, if we can get the value of our discriminant, d is equals to b squared minus 4ac. Okay, b is 4 squared. minus 4 times, what is A? A is 1 and our C is 6. So this is 16 minus 24. That is minus 8. Remember, when your discriminant is less than 0, minus 8 is less than 0. When your discriminant is less than 0, it simply means that the root of that equation is complex. It is not real, which simply means that the curve will not cut the x-axis. So we already know our curve is not going to cut the x-axis. That is 1. And we know it opens up. That is 2. And we know it's going to be on the left because b over a is positive. So it's going to be on the left, okay? And it's not going to cut the x-axis. So definitely it's going to be something like this. It's going to be on the left, okay? It's not going to cut the x-axis, and it's going to open up. Then we know that symmetrical, it is symmetrical at x value of minus 2. So let's look for something like this. So let's start with the first one. The first one here, you can see our curve is cutting, okay? It's cutting x-axis, which is wrong. We need something that will not cut x-axis. So this is already out. Let's go to this one. Yes, this one, you can see this is x-axis here. Our curve is not cutting. So this is a potential solution. Then it is symmetrical at x is equals to 2. You can see because this is 0, 1, 2, 3, 4, minus 5. So it is symmetrical at x is equal to minus 2 because symmetrical simply means it can cut the curve into 2 equal parts. So the 3 conditions that we are looking for in this question is that it must open up, which is opens up, the curve opens up. It must not cut x-axis, which is obeying that. Then it must be symmetrical at minus 2. So this is our answer. Option 2 is our answer. Let's check this one. This one is closing up. So this is already wrong because our curve must opens up. This opens up, correct? It's not cutting x-axis, correct? But it is symmetrical at plus 2. So which is wrong because our curve must be on the left. So our answer here is option 1. Next question. Here is the graph of y is equal to x squared minus 6x plus 3. Okay, we already know here that a is 1, b is minus 6, and c is 3. Here, a is greater than 0. That means our graph should what? Should open up. That is 1. b over a, want to know where our curve is going to be, left or right. That is minus 6 over 1. This is minus 6. So because b over a is negative, our curve should be on the right. Good. Should be on the right. Then let's check our discriminant. Discriminant is b squared minus 4ac. My b is minus 6 squared. So this is 4 times 1 times 3. Okay, so this is 36 minus 12. And this is 24. When your discriminant is greater than 0, it simply means that the roots are real and they are cutting your x-axis. They are real and they are different. So if you look at this graph that they've given you, this opens up, good, and this is on the right, good, and this is cutting the x-axis. So the graph is correct. But what is the question here? I just analyzed here, just analysis. The question says write down the turning point of the graph. The turning point is the point where your gradient changes sign. That means negative gradient changes into positive gradient. If you look at this line here, down, the curve here, down, up to this point, from this point up to this point, that is a negative gradient. Then from this point up to this point, that is a positive gradient. So gradient has changed from negative to positive at this point. So at this point, what is the value of x and y? That is what they're asking you. So here, x, y. At this point here, our y is minus 6. Y is minus 6 because this is 0, 2, 4, 6. So y is minus 6. Let's trace it to x here. So x is 3 because this is 0, 2, 3, 4, 5. So x is 3. So our turning point is 3, minus 6. Easy from the graph. But remember, you can still calculate your turning point by the formula that I gave you, right? We can still get our turning point through that way. Okay? So remember that you have, in this case, this is y minimum, right? Because it opens up. So y minimum is equal to c minus b squared over 4a. What is our c? That is 3 minus, what is our b? Minus 6 squared over 4 times 1. So this is 3 minus 36 over 4. So this is 3 minus 36 over 4, that is 9. 3 minus 9, that is minus 6. So the minimum value of y is at minus 6. And that is why you see it here. Minimum value of y is at minus 6. And the corresponding value of x is 3. Easy. Now, let's take the next. We've done this one. Write down the turning point. We've gotten turning point 3, minus 6. Now, use the graph to find approximate root of the equation. We want to get the root of the equation. Remember here that the equation given to us is x squared, plus 3 is equals to 6x. This is x squared minus 6x plus 3 is equals to 0, right? So this one, I will compare it to what we have. If you compare it to what we have, this is what we have as the curve. This is what we have as the curve is equals to y. So you can see left hand side here is equals to left hand side here, and right hand side y is equals to 0. So it's telling you that at y is equals to 0, what are the values of x? And it's also telling you the root of that equation is where the curve cut the x-axis. So this is the curve here. Where does it cut the x-axis? The curve cut the x-axis at this point and at this point. So this is 1 and this is 0.5. So I can say x is 0.5, or this is 5 and this is 5.5. So this is 5.5. So the root of the equation is 0.5 or 5.5. Now this question, f of x is giving us 2x squared minus 4x minus 6. And they've given us the graph already. This is the graph. Now the first question says, what is the solution set of f of x equal to 0? If f of x is equal to 0. So what they are trying to tell us is that this f of x is this already. So this is 2x squared minus 4x minus 6 is equal to 0. Okay? So here, and this is the function, and they've given us, this is the graph. They've given us the graph here. So that is only tells us when the function is equal to 0, it simply means x value is where your curve is cutting the x-axis. So where is our curve cutting the x-axis? It's cutting at minus 1, so x is minus 1, or, and it's cutting at plus 3. So that is the answer in that case, because we are asked to find f of x equal to 0. Our f of x is already the curve, so where the curve cuts 0, which simply means when y is equal, when f of x is 0, and this is f of x 0 here at this point. So at this point, let's go to the left. You can see it cut the graph here at -1. At this point, let's go to the right. It cuts the graph as 3. So x is -1 or 3. Now, question 2. We're asked to find f of x is equal to -6. Now, what is f of x itself? F of x is 2x squared minus 4x minus 6. Okay? And in this case, they said f of x is equal to -6. Right. So, here, f of x is equal to -6 simply means, let me put it well for you, simply means f of x, okay, is -6, and f of x is something as 2x squared minus 4x minus 6. This is the f of x, which is the curve itself, and is equal to -6. So what that is telling me is that come to f of x, which is y. Our f of x is y. At y equals to -6, we draw a line to the curve. This is the line to the curve. So what is the x value at that particular point? That is what it's saying. So if I draw a line like this now, so it's meeting the curve here. Let's trace it up. That will be x is equals to 2. That is x is equals to 2. Or, you know, you drew a line like this. So at this point, x is 2. At this point, what is x? Trace it up. X is 0. Easy. That is the answer for that. Now, given y coordinate of the vertex of the parabola of the y of the function f of x is equal to 2x squared minus 6x plus 5. Now, whenever you are asked to find y coordinates of the vertex of a parabola is just a curve, which is our quadratic curve. So we are looking for y. Remember that I gave you this formula. Y is equal to x minus that squared plus k. Okay, so this is the y value. That's coordinate, and h is the x value. Okay, so in this case, we are looking for the y coordinates. Okay, so you already know how to get your answer, right? You already know how to get your answer. So let's put this equation or this function in this form. Okay, so that will be f of x is equal to 2 bracket x squared minus 3x plus 5 over 2. Okay, and we have minus 3. So minus 3 times half. That is minus 3 over 2, and we square it. That is 3 over 2 squared, because minus squared is plus. So this is 2 bracket x squared minus 3x. So we had 3 over 2 here plus 5 over 2, and we put minus 3 over 2 squared. Yes. So f of x is equal to 2 bracket. So this is x minus 3 over 2 all squared, right? That is for this one. Okay, then plus, this is 5 over 2 minus 9 over 4. So f of x is equals to 2 bracket x minus 3 over 2 squared. So LCM is 4. This is 10 minus 9. So f of x is 2 bracket x minus 3 over 2 squared. This is 1 over 4. So if I open the bracket, so f of x will be 2 bracket x minus 3 over 2 squared plus 1 over 2. Now, my k, which is my y value, is, so here, my y coordinate is plus 1 over 2, x ordinate, which is h, is 3 over 2. So here, but I'm looking for y. So my y is 1 over 2. So our answer is first answer here, which is 1 over 2. But remember, you can still get that by using y. In this case, our a is greater than 0 because a is 2. If our a is greater than 0, it simply means y minimum. So y minimum is c minus b squared over 4a, right? So what is my c? My c is 5. What is my b? My b is minus 6. Minus 6 squared, that is 36 over 4 times a. 4 times 2, that is 8. Okay? That is 8. 4, yes. 4 times 2, that is 8. So I have 5 minus 36 over 8. So 5 minus 36 over 8. What can go? 4 in 36, 9. 4 in 8, that is 2. See, LCM here, 2. This is 10 minus 1 minus 9. This is 1 over 2. So you can see my y minimum is 1 over 2. So you can use the fast method also to get your answer. Now this question, give the x-intercepts of the parabola of the equation f of x is equal to 2x squared plus 6x minus 36. Now we are asked to find the x-intercepts of this function. Now, x-intercept simply means where the curve cuts the x-axis. That is what it means. And that simply means the root of the equation. So, that is f of x will be equal to 0. That is what it means. That is 2x squared plus 6x minus 36 is equal to 0. So in this case, I have to solve this equation. So we can solve this one here. So let's divide through by 2. So x squared plus 3x minus, this is 18 is equal to 0. You can easily use factorization method for this one. So this is x. This is 6, 3 plus minus. So x is minus 6 or 3. So in that respect, this is what I'm going to have. So x can be 3 when y is equal to 0, because y is equal to 0 for you to have the root of the equation. And x is minus 6 when y is equal to 0, because y is equal to 0 when you have the root of the equation. So this is what I will have. So 3, 0 and minus 6, 0, which is the first option. So this one says all of the following are equations of down-facing parabola, except down-facing parabola simply means facing down like this. Okay? And for it to face down like this, it simply means your A must be greater, must be less than 0. All of the following are equations of down-facing parabola, except down-facing parabola simply means the shape is like this, down-facing parabola. So, and for you to have this, that means A needs to be less than 0, right? So you can see here, the A of this one is minus 6, is less than 0. So this is still correct because it's down-facing parabola. The A here is minus 6, this is down-facing parabola. The A here is minus 1, is less than 0, this is down-facing parabola. The A here is minus 1, which is less than 0, so this is down-facing parabola. But this one here, you can see the function is inside here, so this is not an equation of a down-facing parabola. So our option is this. So you can see I'm using elimination. I've seen that this is correct, this is correct, this is correct. Sorry, this is correct, this is correct, this is correct, this is correct. So except this one here. So that is our answer. Now let's go to the next one. Consider the equation Okay, consider the equation y is equal to 3x squared minus 10x plus 5. The vertex of this parabolic function will be located at. So I'm looking for my x and my y. Remember, we can get our x by using this. Okay, and we can get our y by using c minus b squared over 4a. Or we can just use completing the square to get the same answer. So my x here is minus, what is b? Minus 10. 2 times 3, that's 2 times a. This is 10 over 6. So this is 5 over 3. That is 1. Then let's get y. C, that is 5 minus, what is my b? Minus 10 squared over 4 times 3. So this is 5 minus 100 over 12. So 5 minus 2 here. Okay? Or 4. We can say 4 here. 4 here is 25. 4 here is 3. So LCM is 3. This is 15 minus 25. Okay? So y is equals to minus 10 over 3. So my x, y. X is 5 over 3. And my y is minus 10 over 3. Easy. So 5, 3 and minus 10 over 3. So this is our option here. Easy. Now this question says, find the vertex form of the following quadratic equation. Okay, 2x squared plus 8x minus 1. Now the vertex form is this. Okay, so we want to put this one in this form. So let's say y is equal to 2x squared plus 8x minus 1. So this is 2 bracket x squared plus 4x minus 1 over 2. You already know how to do this. Then you will have this one. So 4 times half, that is 2, then you square it. So x squared plus 4x plus 2 squared minus 1 over 2, then minus 2 squared. So this is 2. So this one here is x plus 2 all squared, then minus half minus 4. So this is x plus 2 all squared minus LCM is 2 here. This is 1 minus 8. 2 is x plus 2 squared minus 9 over 2. So we can open the bracket here. So 2 multiplied this one, 2, that is x plus 2 squared minus 2 times this one, that is 9. So you can see this is now the form of this. So our answer here is 2 bracket x plus 2 squared minus 9. So that is that. The next one here, what is the vertex of function f of x is equal to 2 bracket x minus 4 squared plus 7. Okay? Is it maximum? Is it a maximum or a minimum? The first thing is our a, you know, our equation is our general formula is this. That is the first thing. So our a here is 2. So a is greater than 0. When a is greater than 0, you can only find y minimum. So we already know is a minimum value. So all the maximum is out. So our answer can either be this one or this one. So now let's get our y minimum. Our y minimum already is the value of k, which is 7, and our x value is h, which is 4. So x, y. Our x is 4, our y is 7, and this is minimum. Easy. So 4, 7 minimum, which is this option here. Okay, which of the following is correct for the vertex of the parabola? So f of x is equal to 2x squared plus 8x minus 12. So normally our a here is 2, that means a is greater than 0, and when a is greater than 0 you can only get y minimum. So we already know our answer is either a or c. It cannot be b and d because this is maximum. Now let's get our x. Our x is minus b over 2a. So minus b is 8, 2 times 2, that is minus 8 over 4, that is minus 2. Okay, so we already know that our x is minus 2, and you know you always write like this. So our x is minus 2. We don't need to find y because this is the only minus 2 here for option A and C. So our answer is A. But let's find y just for you to be sure we are correct. So y is c minus b squared over 4a. So what is our c? That is minus 12. What is our b? 8. 8 squared is 64. 4 times 8. 4 times 2, that is 8. Okay, so this is 8 here. So this is minus 12 minus 8 here, that is 8. So minus 12 minus 8, that is minus 20. So y minimum is minus 20. So this is minus 20. So you can see our answer is A. So the next question is saying the above shows part of the graph of the function f of x is equal to x squared minus 2x minus 8. What is the equation of its axis of symmetry? Axis of symmetry simply means you are looking for the value of x, which is at minus b over 2a, because that is where it will cut the graph into 2 equal parts. So minus, what is b? That is minus 2 over 2 times, what is a? 1. So this is 2 over 2, which is 1. So it's going to be at x is equals to 1. Because if you look at here, this is 5, right? So this is 1, 2, 3, 4, 5. So at x equals to 1, if I trace it down, that is where you can see if I trace it down, it will cut the curve into 2 equal parts. So of its axis of symmetry, that is x is equals to 1. Let's check the next question here. The above shows part of the graph of the function this. What is the equation of its axis of symmetry? Still the same. So in this case here, we are using, let me take out this one. Okay, so the function given to us is f of x is equal to x squared plus 2x minus 15. Okay, axis of symmetry is x equals to minus b over 2a. So minus, what is b? 2. 2 times 1. This is minus 2 over 2. This is minus 1. So our axis of symmetry is going to be x is equals to minus 1. So this is 0. This is minus 1. That is what we cut at that point of symmetry. So x is minus 1. That is C. Next question here. It says, what is the equation? What is the equation of its axis of symmetry? So for the axis of symmetry, for this one, f of x is equal to x squared minus 8x plus 12. Axis of symmetry is still x is equals to minus b over 2a. Okay, so minus, what is b? Minus 8 over 2 times 1. So x is 8 over 2 which is 4. So it's going to be at x equals to 4. And this is 4 here. So that is what is going to cut that graph into 2 equal parts symmetry. That is D. Next. So for this one, what is the equation of its axis of symmetry? So we solve it the same way. F of x is equal to minus x squared minus 8x minus 7. So x will be minus b over 2a. That is minus, what is b? Minus 8 over 2 times, what is a? Minus 1. So this is 8 over minus 2. That is minus 4. So x is equals to minus 4. That is option B. The next question. The parabola has its minimum point at 3 and 5. 3 and minus 5. That means x and y. Remember that we have our equation like this. Okay, so they've already told us that our h is 3 and our k is 5. So they've already given us this already. And the y coordinate of the y-intercept is minus 2. The y-intercept is minus 2. That means they're giving us that c is equal to minus 2. What is the equation of the parabola? Okay, the first thing you need to know that for our h, which is x, is same thing as minus b over 2a. Okay? And they've given us our x as 3. So this is 3 is equals to minus b over 2a. So b will be minus 6a. Let's keep this one first. Okay? Then they told us here that our k, yes, our k, which is y minimum, as you know, that is c minus b squared over 4a. We know that. So y minimum here is minus 5 is equals to c. What is our c? Our c is minus 2. Okay, minus b squared over 4a. So this is minus 5. Then this one here, that is plus 2. That is minus b squared over 4a. Okay, so this is minus 3 is equals to minus b squared over 4a. Minus cancel minus. So we can say here 3 is equal to b squared over 4a. So we can easily substitute value of b as minus 6. Okay? So this is 3 is equals to, what is b? Minus 6a squared over 4a. So what do we have? This is 12a is equals to 36a squared. So 36. So I can divide through by 12. So divide through by 12. So this is a is equals to 3a squared. So 3a squared minus a is equals to 0. So this is a bracket 3a minus 1 is equals to 0. Okay, let's take it up here. So a bracket 3a minus 1 is equals to 0. So a is equals to 0 or 1 over 3. I've gotten a. I can get b. B is same thing as minus 6a. So b will be minus 6 bracket 0 or minus 6 bracket 1 over 3. Okay, so b will be 0 or minus 2. So I know my a and I know my b. Since I know my a and I know my b, I can use y is equals to ax squared plus bx plus c. Okay, so y is equals to, what is my a? My a is 1 over 3, that is x squared. What is my b? My b is minus 2x. What is my c? My c is minus 2. So this is my answer here. Easy. So that is 1 over 3x squared minus 2x minus 2, which is option B. Wow, congratulations to you. You were able to stay to the end of this amazing video. Hope to see you in my next video. Bye for now.